Here's a number that should stop you cold. For most of the history of spaceflight, getting 1 kilogram of cargo into orbit cost more than $10,000. That's not the cost of the satellite. That's not the cost of the mission. That's just the price of the ride. A kilogram is about 2 pounds, roughly the weight of a laptop. Imagine paying $10,000 just to mail a laptop to a different floor of your own building. Now here's the part that actually explains the entire aerospace industry. The single biggest expense in that $10,000 price tag wasn't fuel, it wasn't the satellite, it was the rocket itself. Because for 60 years, the rocket was built once, flown once, and then it was gone forever, either burning up on re-entry or crashing into the ocean. Picture an airline that builds a brand new airplane for every single flight, flies it once, and then pushes it off a cliff. That's commercial aviation if it worked the way the rocket industry worked for 6 decades. Stick around, because by the end of this video, you'll understand exactly why owning an aerospace company is one of the hardest businesses on Earth to run profitably. What the one problem is that has bankrupted nearly every private space company that's ever tried, and how a single company actually solved it, turning a graveyard industry into one of the most valuable private businesses in the world. Let's start with why this business is so brutally difficult in the first place. An aerospace company isn't really one business. It's several extremely expensive businesses stacked on top of each other. You need a research and development division capable of solving problems that have never been solved before. You need a manufacturing operation precise enough that a single misaligned bolt can destroy $100 million of hardware. You need launch infrastructure, which means literal concrete and steel launch pads, fuel storage facilities, and control centers. And you need to do all of this while satisfying a regulatory environment built around an underlying assumption that explosions are a normal and expected part of doing business. Most industries treat a major product failure as a catastrophe. The aerospace industry treats it as Tuesday. The capital requirements alone are staggering. Before you've sold a single launch, you're looking at hundreds of millions, sometimes billions of dollars in research, testing, and infrastructure. And unlike a software company, you can't ship a buggy product and patch it later. If your rocket has a flaw, customers and bystanders can die. This is exactly why the aerospace industry has historically had so few major players. It's not that nobody wanted to compete, it's that almost nobody could survive long enough to start generating revenue before running out of cash. Now here's the specific problem that has killed more private space companies than any other single factor: the expendable rocket trap. For decades, the entire business model of spaceflight was built on a simple but devastating economic flaw. Every rocket was a single-use product. You spent months, sometimes years, building an extraordinarily complex machine made of aerospace-grade alloys, custom engines, and guidance systems that had to function perfectly on the very first try, with no opportunity for a dress rehearsal in the actual operating environment. Then you launched it once, and it was gone. Think about the economics of that for a second. Imagine a car manufacturer that builds every car by hand, tests it for the first time the moment a customer drives it off the lot. And then the car is legally required to be destroyed after one trip. You would never recoup your manufacturing costs. You'd be bankrupt within a year. That's not an exaggeration of the old rocket business. That's a fairly accurate description of it. Traditional expendable rockets could cost anywhere from $60 million on the smaller end to well over $200 million for larger vehicles. And government systems like NASA's Space Launch System have run north of $2 billion per launch. Every single one of those rockets, no matter how much it cost to build, flew exactly once before being destroyed. This created a brutal ceiling on the entire industry. Launch prices stayed high because they had to stay high. There was no way to spread the cost of building that rocket across multiple flights. So each customer had to pay enough to cover the entire cost of an entire rocket, every single time. High prices meant fewer customers could afford to launch anything. Fewer customers meant fewer launches. Fewer launches meant less revenue to invest in lowering costs. It was a closed loop, and it kept space access locked behind a price tag that only governments and the largest telecommunications companies could afford. For decades, nobody broke this cycle because breaking it required something that sounded almost absurd on paper. Building a rocket that could survive its own launch, fly itself back down, land upright, and then fly again. This is where Elon Musk's SpaceX enters the picture. And it's worth being precise about what the company actually did, because the popular version of the story tends to oversimplify it. SpaceX didn't invent the idea of a reusable rocket. The concept had existed for decades, and NASA's own space shuttle was partially reusable, though refurbishing it between flights turned out to be almost as expensive as building a new one, which defeated much of the purpose. What SpaceX actually solved was something more specific and more difficult: how to build a rocket that could be refurbished and reflown cheaply enough and frequently enough that the economics actually worked out in the company's favor. The solution centered on the Falcon 9 rocket and its first stage booster, the bottom section that does the heavy lifting during the initial minutes of launch, and historically was the most expensive part of any rocket to build. Instead of letting that booster fall into the ocean after doing its job, SpaceX engineered it to flip around, reignite its engines, and fly itself back down to a landing pad or a floating drone ship at sea, landing upright on 4 extendable legs. The financial logic here is the same logic behind why airlines don't throw away airplanes after one flight. If you can spread the enormous upfront cost of building a complex piece of hardware across dozens of flights instead of just one, your cost per flight drops dramatically, even after you account for the expense of inspecting, refurbishing, and relaunching that hardware. And the numbers back this up in a very real way. SpaceX has driven the cost of sending cargo to orbit down from that historical figure of around $10,000 per kilogram to roughly $2,500 per kilogram for the Falcon 9, depending on the mission, with internal costs for its own missions reportedly even lower than that. A Falcon 9 booster in the company's current generation has been reflown well over 20 times, with some boosters pushing past the high 20s, a number that would have sounded like science fiction to the rest of the industry a generation ago. Refurbishing a flown booster costs a small fraction of building a brand new one, which means each additional flight on the same piece of hardware becomes dramatically more profitable than the one before it. But solving the reusability problem created a second, less obvious problem, and this is where the real business genius of SpaceX shows up. If you build a rocket that's cheap enough to fly dozens of times, you suddenly have an enormous amount of cheap launch capacity. But that capacity is worthless unless you have enough customers who actually want to launch things. Reusability only pays off through volume, and for most of spaceflight history, there simply weren't enough satellites, missions, or customers in the world to keep a high-frequency reusable rocket business busy. This is the second trap that catches reusability-focused companies. You solve the cost problem on the hardware side, and then you discover you don't have enough demand to actually use your new capacity efficiently. A reusable rocket flown only a few times a year barely beats the economics of an expendable one, because you still have to maintain all that infrastructure, all that staff, and all that overhead, regardless of how many times you fly. SpaceX's solution to this second problem is one of the more unusual moves in modern business strategy. If the market doesn't have enough demand for your product, become your own biggest customer. That's exactly what the Starlink satellite internet project does for SpaceX. Starlink needed thousands of satellites in low Earth orbit to provide global broadband coverage, and SpaceX, conveniently, happened to own a rocket company that needed a reason to launch constantly. A large share of all Falcon 9 missions in any given year are now dedicated specifically to deploying Starlink satellites. SpaceX essentially built its own demand to guarantee a high launch cadence for its own rockets, which in turn made each individual launch cheaper, which in turn made the Falcon 9 even more attractive to outside commercial customers who could now ride alongside an already highly efficient operation. This created the kind of business flywheel that's genuinely rare to see executed well. More launches drove down the cost per launch. Lower costs made commercial launch contracts more attractive to outside customers. Outside customer revenue funded further development. And Starlink itself grew into a substantial revenue stream of its own, generating billions of dollars annually and providing the company with an internal source of demand that doesn't depend on convincing outside customers to take a risk on a new kind of rocket. It's worth pausing here to be fair about something, because not every part of this story is a clean success. Reusability is not free. SpaceX reportedly spent well over $1 billion developing the technology before it ever generated a cent of savings. And the company has been famously private about its full financial picture, since it remains privately held and isn't required to publish detailed earnings the way public companies are. Outside analysts have to piece together estimates from public statements, government contracts, and industry comparisons, rather than working from a clean balance sheet. There's also a structural debate among aerospace economists about exactly how much of the savings from reusability actually gets passed on to customers versus being absorbed by the company to fund the next generation of hardware, which at SpaceX right now means the much larger, fully reusable Starship vehicle currently under development in Texas. Independent research has suggested that the economics of a reusable rocket program only work if the company can sustain something like 6 to 9 launches per vehicle per year at minimum. Fall below that threshold, and the savings from reusability can be eaten alive by the fixed cost of maintaining the refurbishment infrastructure in the first place. This is exactly why European aerospace companies, which haven't had access to anything like the volume of in-house demand that Starlink provides, have struggled to justify making the same leap into reusable systems. The technology isn't the only barrier. The demand to make that technology pay off is just as important, and that's a problem money alone doesn't automatically solve. So let's bring this back to the original problem, the expendable rocket trap that kept space access locked behind impossibly high prices for 60 years. The solution wasn't simply building a rocket that could land itself. That was necessary, but not sufficient on its own. The full solution required two things happening together: a piece of hardware durable and cheap enough to refly profitably, and a source of demand large and consistent enough to actually keep that hardware flying often enough for the math to work. SpaceX solved the first half with the Falcon 9's landing system. It solved the second half by building Starlink, essentially manufacturing its own customer base when the broader market wasn't yet ready to provide one. Neither half alone would have transformed the industry. Together, they broke a 60-year economic deadlock and dropped the practical cost of reaching orbit by a factor that would have seemed implausible to anyone running an aerospace company in the decades before it happened. So here's the honest summary of what it actually takes to own an aerospace company. The barriers to entry are some of the highest in any industry on Earth, requiring enormous upfront capital, tolerance for spectacular and very public failure, and a regulatory environment that assumes things will occasionally explode. The central economic trap that has bankrupted company after company is the cost of building expensive hardware that can only be used once, creating a ceiling on prices that locks out most potential customers. And the only proven way out of that trap so far has been a combination most competitors still haven't fully replicated. Build hardware that survives its own use, and build or find enough demand to keep that hardware flying constantly enough to make the math work. The laptop that used to cost $10,000 to mail to orbit now costs a small fraction of that, and the gap keeps shrinking. That's not just an engineering story. It's a business model story about what happens when a company finally solves both halves of a problem that the rest of an entire industry had only ever managed to solve halfway. If you found this breakdown interesting, there's a lot more where the economics of massive, high-stakes industries get genuinely strange once you look closely at the numbers behind them. Let me know in the comments what industry you want broken down like this next. Thanks for watching, and I'll see you in the next one.